Hi everyone, am I audible?
Hello, yes, sir.
All good?
Yes, sir.
Any doubts on the last class?
No, sir.
No. Okay. Insha, what about you?
No, sir.
Okay. Let's wait few minutes, okay? Then we'll start the class. Okay, let's start with the question. The question says, find if the greatest integer function f from R to R given by f of x equals to gif of x is whether 1 1 or onto. Okay, you guys know what this function is? Greatest integer function.
The highest value, ceiling value.
Ceiling value. If you have 4.3 GIF, then what is the value? Hmm?
4,
4. Very good. And if you have minus 1.2,
-2.
minus 2. Very good. Okay, please do this.
Sir, it's not 1, 1.
Okay, it's not 1 1. Zaina, what about you?
Yes, sir, it's not 1 1.
Very good. It's not 1 1 because if you put 4.2 also, get 4. If you 4.4, then also 4, right? So many elements are connected or related with one single element. So this is not 1 1. Check for onto.
So the range is different, so it's not onto.
Very good. Range is different because it only produces integral values, right? Integers only. And on the codomain, we have all real numbers. So how can any real number or rational numbers will be associated with this? Okay, so this is not onto also. Okay. Got it?
Yes, sir.
Check for f from R to R given by f of x equals to cos x for all x belongs to R. Correct answer, Zana. Insha got the answer. Very good. So cos x is not 1 1 or onto. Okay, to check 1 1, there is another test which is called horizontal line test. Okay, this is just a trick kind of thing. If you have the graph of a function, if you have graph of the function and you draw a horizontal line, okay, parallel to x-axis, and if it cuts many points, then this is many one. If it cuts only in a single point, suppose you have function like this, it cuts wherever you draw the line, it cuts only at a single point, then it is a one function. Okay, and on to why not? Because the range of cos x is from -1 to 1. So any number beyond this is not related to any pre-image. So this is not onto also. Okay. Let a equals to r minus 2 and b equals to r minus 1 if a or if f is from a to b is a mapping defined as f of x equals to x minus 1 upon x minus 2. Find if it's bijection. Hello, Madhya.
Hello, sir.
All good?
Hello, sir.
Okay, please try to solve this question on your screen. Okay, Zaina, Insha got the answer. So to check 1, again we'll say f of x1 is equal to f of x2. So we have x1 minus 1 upon x2 minus 2, or x1 minus 2, which is equal to x2 minus 1 upon x2 minus 2. Let's cross multiply x1 minus 1. x2 minus 2 is equals to x2 minus 1 times x1 minus 2. So it becomes x1 x2 minus 2x1 minus x2 plus 2 is equals to x1 x2 minus 2x2 minus x1 plus 2. This is cancelled. This is cancelled. Let's bring this minus x1 to this side, so it becomes plus. So minus x1 is equals to minus x2, which is x1 equals to x2. So it is 1 1. And for onto also, how do we check? There will always be a rational number, right? For which x minus 1, x minus 2. So we have y equals to x minus 1 upon x minus 2. We can multiply. This is xy minus 2y is equals to x minus 1. And xy minus x is equals to minus 1 plus 2y. X is equals to minus 1 plus 2y upon y minus 1. So here we can see all the numbers that are associated. We can find a rational number. Okay. Yes, all of you, this is clear.
Yes, sir.
Okay. Let's see. Okay. So we are absolutely clear about 1 1 and onto function, right? Which functions are 1 1, which functions are onto, and so on. But why is the need required here? What is the need of studying this? What is the point? The point is, can anyone tell me if this is a function? We have a function here 1, 2, 3, 4, 5, A, B, C, D, E. If this is a function or not? Is this a function?
Yes, sir.
Yes. Okay. Right. This is a function. Suppose we have another one. Is this a function?
No.
Why not?
Here, there is no unique image for 3.
Right. And also 7 is not related to any element, right?
Yes,
7
yes.
should be also related. Okay. So we know the condition is that all the elements of set A should be uniquely related to elements of B, and all the elements should be related, right? No element should be vacant. So if this is a function, when we look from left to right, then inverse would be when we look from right to left, just the opposite behavior. So if you look at this function, we know this is a function. Let me erase this one. But when you look from right to left, does it become a function? If I say this is a set A, this is set B, a function from A to B, will it be a function? Nobody understood what I asked? What I'm saying is, if we have a set like this, suppose, A is connected to 1, B is connected to 2, C is connected to D is to 3, E is to 4. Is this a function? Yes or no? Is this a function from A to B?
Yes.
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 Yes,
Suppose I look from this way. This is the initial set. This is the codomain. Will it be a function?
No.
Why not?
Like again the same reason, like 2 is having again two not
Three
unique
images.
image. Yeah,
Very good.
2 images.
Right? Yes. So we know that if we cannot get a function in the reverse order, that means inverse of this function is not possible. Yes or no?
Yes, sir.
I can say this in confidence. That means if we have to make a function inverse, then it should be 1, 1 and onto, because no element here, right? No element here should be left out, and all should have unique image also. So to create if inverse function, it must be, or let's write, for a function to be invertible, it must be 1, 1 and onto. Okay, everyone is clear about this? Please note it down. Done? Composite function. Have you guys studied this in school? Composite functions? I don't think so. It is deleted. Okay, but hardly 10 minutes. It's very required. Composite function is, suppose we have f of x is equals to x square and g of x is 3x. Okay. We have to find f of g of x. This is known as composite function. What we do, if we have to find f of 0, what we do is replace x with 0, so it becomes 0 square. If we have to find f of 1, we replace x with 1, we get 1 square. Here we are replacing x with g of x. So the equation becomes g of x whole square. Understood, everyone? Yes or no?
Yes, sir.
So it becomes 3x whole square, g of x is 3x, so 9x square. And if we have to find g of f of x, we do the reverse order. In the place of x here, in the g of x, we replace f of x, so it becomes 3f of x. So 3 times x square. This is known as composite function. Okay. Why am I saying this? Because, write the next thing. Okay, please note it down first. Then I'll move on. Okay. Note down. F of x and g of x are two functions such that f of g of x is equals to g of f of x, which is equals to x. Then we say f of x is inverse of g of x and vice versa. Okay. And we write g of x is equals to f inverse x. Please remember that this power here -1 is not power actually. This is a symbol. Okay. If you write like this, f inverse x is 1 upon f of x, they will put you in jail. Okay. So never do this. This is a crime. This is just a symbol to denote the inverse. This is not the power. Okay. Please note it down. Okay. Done. Yes or no, everyone?
Yes, sir.
Okay. If f of x is 2x plus 3 and g of x is x minus 3 by 2, find f of g of x, and this is also written as f of g, okay, and g of f of x. Okay, this is a question for you guys. Madhya, what chapters is currently going on in school? Application of derivative, and all the chapters before that is complete. Continuity, differentiability. Okay, you have understood that. Okay, got it. Okay, do you need classes on that also? Continuity, differentiability. Application of derivatives is also difficult chapters. Yes. Okay, don't worry, got it. Try to solve this one. Yes, Madhya, got it. We have talked to the team. We are doing something about it. Don't worry. Okay, you will get the response from the team very soon. Anyone solve this? F of g of x. We just replace x with g of x in the function of f of x. So 2 times x, that means g of x plus 3. So 2 times g of x is x minus 3 by 2 and plus 3. This is gone. What we have, x, 3 and minus 3 also cancel out. Okay. So f of g of x is x. Now let's find g of f of x. So g of x is x minus 3 by 2, but we are replacing with f of x. So f of x minus 3 by 2. And f of x is what? 2x plus 3. So 2x plus 3 minus 3 by 2. This is gone. Then this is gone. So we have x. So you guys can see that f of g of x and g of f of x both are x. That means f of x and g of x are what? Inverse functions of each other. Got it? All of you?
Yes, sir.
Yes.
Okay. How to find inverse? Inverse we find 2 steps. Write x in terms of y. Replace x with y. For an example, in the same question, we have y equals to 2x plus 3. So we will do y minus 3 is equals to 2x. This implies x is equals to y minus 3 by 2. So we wrote y in terms of x. Okay. So we'll replace this with x here and we got the answer. Yes, I know, Madhya, this topic is deleted for boards, but understanding is very crucial. Okay, this composite function and inverse functions hardly takes 15 minutes. Okay, that is why I do not skip this. Okay, they will not be asking you questions directly from this, but this is very important. Okay, all right, everyone. Got it? Yes or no?
Yes.
Okay, let me give you questions. 2 questions on this. Please find inverse of this function. Got the answer, everyone? Anyone found the inverse to this question? No. This is xy minus 2y is equals to x minus 1. So let's bring x terms together, xy minus x, and this is 2y minus 1. X common, so it will be 2y minus 1 upon y minus 1. Replace x with y, so y equals to 2x minus 1 upon x minus 1. This is the inverse to this function. Okay? Clear, everyone? Zaina, Madhya?
Yes, sir.
Okay. So this chapter is also officially over. Now, investigate. Okay. Inverse Tigo. Okay, so I told you that to find inverse of any function, that function has to be 1, 1 and onto, right? Yes or no?
Yes, sir.
And we also saw that cos x was not 1, 1 and onto. Yes, we did a question.
Yes, sir.
So can we find cos inverse if this is not 1, 1 and onto?
No.
But there is a chapter named trigonometric function. So what is happening? Am I lying? Any answers? If cos x is not 1, 1 and onto, then how can we find cos inverse x? See, what we do is, if if we have sin x graph as this, okay, what we do is we say let's restrict this graph to some domain, a fixed domain. Okay, so what they do is they draw this graph from here to here only, and we do all the calculations between this graph only. They restrict the domain. They say domain is from minus pi by 2 to pi by 2 only. And in this part, it is 1, 1, right? If you do horizontal line test, you can see that it is 1, 1. Okay. And also they restrict the range also. They say range is from minus 1 to 1. So they restrict the range also. So it becomes onto. So in a restricted domain, trigonometric functions becomes 1, 1 and onto. Then what we do is find inverse trigonometric functions. Is it clear?
Yes, sir.
Okay. And this is what we know as principal range or principal domain. You must have studied this in school, but this is the reason. And now one thing, if someone chooses this part, it is well and good. Someone can also choose this part, no issues. But the theories change according to the domain you choose. Okay, so generally what we do is we deal with this much domain only. Okay, so let's jump into investigative functions and their graphs. Okay, write down graphs of investigative functions. Okay, very important. First one is sin x and sin inverse x. Here I'll show you what sin x looks like. Here I'll show you what is sin inverse x. So sin x graphs, a sin x graph, as I told you, will be restricted from minus pi by 2 to pi by 2. This value is of x. Maximum is 1 and minimum is minus 1. Okay, this is sin x. And this will be pi, this is pi, 2 pi, and so on. So here, if we say domain of sin x will be R, Okay, generally, and the range of sin x is -1 to 1. But when we draw the inverse of this function, remember in inverse function, x becomes y becomes x. So if you look at this graph, at pi by 2, we had 1. So this point was pi by 2 comma 1. At inverse, it will change. So the points will have 1 comma pi by 2. So at x will plot 1 and at y will have pi by 2. Okay, this point was minus pi by 2 comma minus 1. So we'll draw -1 comma minus pi by 2. Okay, got it everyone? So the graph looks like this. And if you see here domain, the range becomes domain. So domain will be from -1 to 1, and range, as we have restricted the domain here, will be minus pi by 2 to pi by 2. Is everyone clear why range is minus pi by 2 to pi by 2? Yes or no? No, everyone, Zaina, Madia?
Yes, sir.
Okay, please note it down. Done, everyone?
Yes, sir.
Okay. Next one is cos x and cos inverse x. So cos x graph is very easy. If you remember, we restrict this from 0 to pi. 0 to pi. This is again 1. And this is -1. Domain becomes same, which is r. Range is same as sign, which is -1 to 1. If we plot cos inverse, then this point here, it is pi comma -1. So it will become -1 comma pi. So at -1, it becomes pi. Okay. And this is 0 comma 1. So at 1, it becomes 0. So the value is something, the graph is something like this. This value is pi by 2 because this is pi by 2 comma 0. Madhya, not directly, they do not ask these graphs directly, but yes, some uses are there. Okay. Here domain becomes range. This range here becomes domain. So -1 to 1. And range we have restricted from 0 to pi. Note it down. Done, everyone?
Done.
Okay. Next is tan x and tan inverse x. If anyone remembers the graph of tan x, then here we restrict it to minus pi by 2 to pi by 2. It is pi by 2. This value here is minus pi by 2. At pi by 2, it turns to infinite. At minus pi by 2, it turns to minus infinite. Okay. Here domain becomes r minus 1 plus 1 by pi by 2. This is 11 because anywhere you put pi by 2 or multiple of pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, so on, it becomes infinite. So we exclude it from its domain. And range is r. For tan x, range is r, minus infinite to infinite. Okay, so tan inverse x, this point is pi by 2 comma infinite. So at infinite, it should become pi by 2. So let's say this is pi by 2. So at infinite, it should become pi by 2. And at minus pi by 2, here we have minus infinite. So at minus infinite, it should become minus pi by 2. So graph is something like this. Okay. Domain is R because in tan x, range was R. Range here is restricted, which is minus pi by 2 to pi by 2, but both are not included because if you include this, it becomes infinite. Okay, please remember this. At tan x, minus pi by 2 and pi by 2 are not included.
So what is the range for tan x?
The range for tan x is R, all real numbers, minus infinite to infinite.
Yes.
Done, everyone?
Yes, sir.
Okay. Next one is cortex and cot inverse x. The graph of cortex is similar to tan x. It just flows in different direction. In like this. Okay, it keeps on repeating and so on, but we restrict it from 0 to pi. Okay, we restrict it from 0 to pi. So here domain becomes r minus n pi. That means if you put 2 pi, 3 pi, 4 pi, any pi in cortex, it becomes infinite. So we remove it from domain. The range again is r, which is minus infinite to infinite. And for cot inverse, we are restricting from 0 to pi. So at 0, it is infinite. That means at infinite, it should be 0. At infinite, it should be 0. And at pi, it is minus infinite. So at minus infinite, it should become pi. Okay. So this is the kind of graph we have for cortex. This is pi by 2. Domain is r because the range of cortex is r. Range is 0 to pi excluding both these two. Okay, note it down.
Done, sir.
Okay. Next one is cosec. Okay, cosec graph is something like this, if you remember. Okay. So what we do here is also restrict the graph from minus pi by 2 to pi by 2. So remember at cos x, we have two portions of graph. This is minus pi by 2 to pi by 2. Okay, this part, let me mark it in red, this part and this part. We have two portions. So domain here for cos x is r minus n pi again, because if you put pi values, it becomes infinite or minus infinite. The range becomes r minus minus 1 to 1. Okay, it cannot be minus 1 to 1. This space is vacuum. For cosec inverse x, if you look at this part, this red part, the first part, it is ending at pi by 2 and becomes 1. At pi by 2, it is 1. So at 1, it should be pi by 2. At 0, it becomes infinite. So at 0, it should become infinite. So graph is something like this. Okay. Now the second part, it is minus pi by 2, minus 1. So at minus 1, it is minus pi by 2. And at 0, it becomes minus infinite. So at 0, it should become minus infinite. Something like this. This is the graph of cosec inverse x. Okay. Domain is the same as range of previous one, which is r minus minus 1 to 1. And range becomes minus pi by 2 to pi by 2, close brackets, minus 0. Okay. Because 0 is not available here. Noted. Done.
Yes.
Next is last one, which is sec x. And sec inverse x. For this graph, it just shifts something like this. Okay. This value is pi by 2. Again, we have like this. So we restrict the graph from 0 to pi. So again, we have two portions. So it's pi by 2, this value is pi. So 0 to pi. Domain becomes minus 1 plus 1 pi by 2. It becomes infinite at pi by 2. And range becomes r minus minus 1 to 1. If you draw the inverse one, again we have two questions. So if you look at the first part, it is at 0, it is 1. At 0, it is 1. So at 1, it should be 0, this point. And for here pi by 2 infinite, so at infinite it should become pi by 2. So something like this. For the second part here, at pi by 2 it becomes minus infinite, so at minus infinite it should become pi by 2, and at pi it becomes minus 1, so at minus 1 it should become pi. So graph is like this, two portion. Domain becomes same as range, r minus minus 1 to 1, and range is 0 to pi and minus pi by 2 restricted. Okay. Yes or no, Zaina?
Yes, sir.
Okay, note it down. Tell me when you are done. Done, Zaina?
No, sir. 1 minute.
Okay.
Yes, sir.
Okay. So in the next class, please memorize the domain and range only. Okay. Look at the graphs, and if you just know the